Okay, gents, as you can see, today's revision lesson is about Brownian motion. And Brownian motion is a very important discovery because it basically proved that the kinetic theory of gases was correct, that all gases are made of gas molecules and basically they're all moving around all the time. It was discovered by, by Robert Brown, who was an English botanist from Scotland, and in the 18th, 19th century he was interested in pollen grains, and one day he was looking down his microscope at some pollen grains, and he noticed some pollen grains, and he noticed a very surprising thing, which was that they were jiggling around all the time, and that's what he decided to call Brownian motion. And he did try to explain it, but his explanation wasn't a very good one. His conclusion was that the pollen grains were moving around in this jiggly way because they were alive, and now we know that that's not the correct answer, but it did lead to a very important theory in biology, and that's shown here. You probably remember this from year 7, so you're getting 2 revision lessons for the price of 1 here. In biology, do you remember, here's M, all living things, characteristics of living things, all living things move, and that's what Robert Brown discovered. And then later people went on to discover that all living things reproduce, they all have sex, they all germinate, or generate, they all reproduce, they all eat, and they all have nutrition. So that's the Mrs. Graham theory of living things in biology. And I've written HSW down here to remind me to point out this important thing, HSW, how science works. You remember when we studied that Robert Brown discovered Brownian motion completely by accident. And that's a very important idea in how science works, that all the most important discoveries have been made by accident. For example, if you think of Isaac Newton with his apple, when that fell on his head, he discovered gravity, and that was a complete accident. Another example would be Henri Becquerel, who discovered radioactivity. Do you remember he was working in Paris, and he was putting his uranium rock on the windowsill in the sunshine and to fill it up with radiation, but when it was a cloudy day, he left it in the drawer next to some photographic paper, and when he developed the paper he found that it was false, and that's how he discovered radioactivity. And he went on from that to discover alpha, beta, gamma radiation and so on, and then, do you remember I told you about the scientists have now discovered basically delta particles, sigma, omega particles, in fact the whole Greek alphabet. And without that we wouldn't have things like X-rays and microwave ovens and mobile phones. So another very important example of an accidental discovery in science. And let's go back to Brownian motion. How do we observe Brownian motion? Well, we use the Whitley Bay smoke cell. And well, Whitley Bay is like a fishing village in Newcastle, somewhere up there, and there the fishermen, when they can't go out to sea because it's rough or bad weather, they stay at home, and in their workshops they make small pieces of scientific equipment, and one example is the smoke cell. Here's how it works. The smoke goes in a small cell over here, over here, and there's a light. When the light lights up, light from the light passes through this glass rod, which acts as a lens and focuses the light onto the smoke in the smoke cell, and the light is reflected up into the microscope, we're reflected down into the microscope here. And it wasn't really properly explained until years afterwards, centuries afterwards, when this guy, Albert Einstein came along, and he was able to show that what really was going on was that there were very big smoke molecules and very small air molecules, and the air molecules are basically bashing into those smoke molecules all the time and moving them around, bashing into them from all sides, but sometimes more from one side than another, and so the smoke molecules move around. So that was Albert Einstein's contribution. And remember, in an exam, you mustn't say that you can see the air molecules moving around, because they're much too small. They're much smaller than the wavelength of light, and so the light just goes straight past them and bounces off the smoke particles. Okay, so if we go back to this lady here, Jean Perrin, she was a French physicist, and she did a really nice piece of work because she sat for hours and hours looking at smoke particles. I think she probably used smoke from one of her gold wires, you know, and she plotted the position of 3 smoke particles over a long period of time, and that's a very nice drawing. And you can see one surprising thing is they never even bumped into each other, which I don't think has ever been explained. Anyway, to you young ladies out there, I would say, don't ever say that all physicists are boring old men with grey hair. Here's a nice young French lady who did a lot of important work on Brownian motion. Okay, so let's finish off with a little bit of a film from I found on Bookface YouTube, and it shows you some Brownian motion in action. Just going to zoom in on that for you, and I'll do this. See better. Can't actually see myself ever since that. I've had spots in my eyes ever since that trip to Sellafield. Cut, I think.